All right, so packet 5, class 12. Mostly today was the hall projects. I was type 2B, projectile motion. And I was talking to my son today. We're texting back and forth, and he's 23. He's an engineer down in Austin. He does water resources, and he's traveling the world. And he got caught up in Spain during the COVID time, so he had to come back. But he's getting ready to head to Argentina here pretty soon. So he does all world traveling, but makes enough money to go travel and comes back. But we were talking about understanding, and he listens to these podcasts and stuff and reads books. But so the idea that understanding is really difficult and very slow process, true understanding, and it's hard to come by in high schools. And that's probably why I'm the slowest physics teacher in Oklahoma, maybe the slowest teacher in the country, because rather than you memorizing formulas or plugging in numbers, I want you to understand the concept. And this came to fruition today. Today with the lab out in the hallway, it was pretty obvious who kind of understood what was going on, who didn't. We can all write formulas and plug in numbers, but can you actually go out and do it when you have real physics? Okay, so to keep up with in-class kids, by tomorrow you want to have the first 1 and 2. We did 6 together, but you want to have 1 and 2 done on 5-5 for those. We're just going to slowly go through those, and when we have extra time, I'll throw one in as homework. I know you also have. Let me stop this sharing for a second. You also have these. Hello. Hold on. Why aren't we coming up? You not see me? Oh. Could you guys see my screen when I was sharing it?
Yeah, we can see it.
Okay, but you can't see me. Huh. The camera's not on. What the? Oh, that's weird. My camera's not on. Okay. Well, all right. So I guess forget that. We'll just go ahead and share the screen. That's not good. All right, so what I was showing you was now I have set 1 of 2 and set 2 of 2 of the practice problems. And you're going to turn those in for you all. It'll be Friday, I think. For them, it's Thursday next week. And you're going to get they get a dyno, so you get 3 points for every one you do correctly. And you should do them correctly because you look up you do the QR code and it gives you so I'll put some more of those on the front porch if you want to combine, get them. Otherwise you can just print PDF. There's PDFs, you can print those off. So that's something that'll always be going on until next Thursday, Friday. Okay. So today we're going to spend the time kind of going over what they went over. And then I'll show you a video or two of what happened in the hallway, and then we'll call her quits. So Tuesday, our object was to get the V0. And the typical V0, let's just throw out a number. The typical V0 students were getting when they plugged in, remember they're shooting, I showed you some video, but they're shooting the ball up and it's hitting the top of books. And so the typical V0 is around 25 feet per second. So we'll just say V0 equals 25 feet per second. Okay, now what we got to do though is using these values, and everybody had a different, launcher. So how about we let's go from the table. We'll look at 2 scenarios. Let's look at 2. We'll look at the 2 scenario launcher on floor 40 degrees. Okay. And then we'll look at launcher on table 20 degrees. We'll look at 2 and 5. So they had to figure out what their delta X was going to be. It's not range, not the same thing as range, because range is only if it's a type 2A problem. These are type 2B problems. So the first thing we'll look at is let's go for the launch. Let's go over 5 first. So if we're dealing with 5, we're doing the launcher on the table, 20 degrees to the target. Okay. Launch, and then the table, the target's over here. And the target is, they're huge targets, like 4 poster boards put together. And so this one, it says that we said 25 feet per second was our muzzle velocity. We figured that out on Tuesday. And for this particular group, that would be 20 degrees. And then they had to measure from the center of the barrel to the floor. And a typical value there was 3.5 feet negative. So delta Y was negative 3.5 feet in this group's case. Okay, so their goal was to first do the math and figure out what is my delta X going to be. It's not the same delta X as Tuesday. What's my delta X going to be? And then put the target right there. So their first shot, they get 3 shots at it, but they want the first shot to mean something, right? You get to adjust your target in the second shot and the third shot, but the first shot is all math. So some nailed it on the first shot. Others, we got some wild answers, and I looked at, I was kind of doing quality control, and they wouldn't use a negative and all this kind of stuff, but sometimes they were doing it right. They still got weird numbers. Anyway, so for the we have delta X equals V naught cosine theta times T, and we're not finding time, but we go over to blue. We can use the blue quad. T equals the V naught sine theta plus or minus square root of V naught sine theta squared minus 2G delta Y all over G. So what we're doing is we're going to take this and we're going to plug it in for time. And then then we can figure out, or just from measuring a few things, we can figure out what our delta X should be. Okay, so let's write the whole thing out, and then we'll kind of diagram what each thing is. I'm just doing what we did in class. So give me some room down here. So, by the way, Miranda brought me some goodie. Brought me dinner last night. Oh my God, that was amazing. Delta X. My wife and I ate it. Loved it. V naught cosine theta times square root of, COVID fog, times bracket V naught sine theta plus or minus. Now, if you're shooting up from the floor, you will get 2 positive times, the plus and the minus. But you tell me, which one are you going to use, the plus or the minus?
Plus?
Yeah, not the minus, because the minus is when it's on the way up, and the plus, it's good. The thing is, the ball's got to hit the apex, then come back down and hit the target. So that messed up some students. We talked about it; they figured it out. But okay, now I want to say what each one of these things come from. All over G. Now it's all one big equation, and so the V naught, this came from Tuesday. That's the muzzle velocity. So that came from Tuesday. That's the only thing that came from Tuesday. Theta, the angle, is from what you read, like in this case, for going from the table down, it's 20 degrees. So that we'll just say, in this case, we'll say 20 degrees. They had to show me all this before they went out the hallway. So for ours, that's 20 degrees. And then G, of course, we're doing English units, feet, so 32.2 feet per second squared. And the delta Y, and that's G there too. And the delta Y, you have to measure with a ruler or with a meter stick. And they measured typical, if we're going down, typical group got about negative 3.5 feet. Okay. So then they had to do all the number crunching. And we're saying on this V naught, we're going to call that the generic 25 feet per second. It ranged between 24 and 30. We'll just say 25 feet per second. So you punch all that in and you get a value for delta X. And then you go out to the hall and you measure that, delta X. Okay. Now, the difference between shooting from a table down to the floor is if you shoot from the table to the floor, that delta Y is negative. If you shoot from the floor to the table, the delta Y is positive. That's really the only big difference. Okay, now I want to show you, we'll be done here pretty soon. I want to show you if it works. Let me share the screen for my photos. I hope they've been transferred over. This is pretty raw. I haven't had a chance to edit this or anything. And the kids have got some video too. They're going to put it, they told me they'd put it in the Facebook group. So, photos. Well, okay. So, like that's third hour. Oh, you can't see. Sorry, I got to share the screen. Share. I'm going to change. I'm going to stop sharing for a second. Maybe. Okay, let's just share a different screen. Okay, I'm going to share that one now. Okay, so here we are. This is third hour out there gathered around. We had tables out in the hallway, and there's two tables here. And they were shooting. This is when they were still figuring it all out. They were shooting from the table down to the floor, and then the other table, they were shooting from the floor to the table. And so, and here is some video from second hour. It's still loading, I see. And I don't know why second hour had those two targets like that, but kind of messed them up. So this is the south end where they're shooting up to the table. Those people were. Okay, we're slowly loading this thing. Then I'll play it for you. We did that. It took the entire hour. In fact, first hour didn't get done. It took the entire hour to kind of get it all straightened out because they kept messing up on their numbers. And I kept having to go back and do it again because they kept, they wouldn't do it. Okay, it's almost ready. They wouldn't make it negative, or they screwed up when they were in radians or whatever. It just shows that you're really doing something. You have to know what you're doing, or you're not getting points. Okay, now it's ready. Almost. Okay, here we go. Yeah, you guys will shoot that way. T will shoot that way. Two shoot this way. You're gonna have to go with like a 25 feet per second. It's pretty much an average. Just go with 25 feet per second as you're being out there. This way? And you want to film it to see if it's. Wait, no. Is that good? Yeah, that's good. Okay. Yeah, there you go. I think it's on the right notch. All the way back. Oh, now you got to video that. I did. And okay, so they videoed it. I think it hit the 4. You had to prove a 4 or 6. And for some reason, my camera's not working, but okay, it was working. Anyway, so that's the thing, and we all got the points, and that's pretty much all we did today. Tomorrow we'll start momentum, conservation momentum, which is 5.6, but 5.6 will not be on the test next week. It goes 5.1 through 5.5. Okay, I wish you could see me, but you can't. So I guess we're going to call her good and shut her down unless you have a question. You guys can take off. If you have a question, stick around. Tomorrow we'll hit momentum.
I have a question.
Yeah.
So on 5 point, on the gold standard part.
Yeah.
Is that 5 point? Yeah, 5.5 on number 1.
Yeah.
Kept getting an answer that's like far away from what the.
Which one is it you're working on?
Number 1.
Number one. All right, hold on a second. Number one. I'm looking for, here we go. Number one, okay. Here's my work on it. This is what I did on number one.
Oh, I did the same thing, but I kept on getting a weird answer.
You squared your time, I guess. And you got to square.
Oh,
That's usually the problem if you're.
yeah, I didn't square it.
There you go. That's probably it.
All right, thank you.
Okay, you bet. I'll see you tomorrow.